Lesson 79 is about systems of equations with subscripted variables. Now, back in Lesson 71, we talked about subscripted variables and we applied those to simultaneous equation problems, and you just learned how to solve simultaneous equations where there were subscripted variables instead of the variables being x and y. Now remember, subscripted variables, those are just a variable with a small letter subscripted. That's what that small d means, is a subscript. The reason we use subscripted variables is for word problems where we're describing a quantity like an apple or an orange or a dime or a nickel or something like that. And when we set up a problem based on that word problem, we're trying to solve an equation from that word problem, that just helps us describe our variables better if they relate back to the word problem. In this lesson, you'll just get some practice on using subscripted variables. You'll be applying this later in word problems. Look at this equation. It says that you've been given that relationship RCTC plus RVTV equals 370. You've been given that RV equals 60, RC equals 50, and TC equals 5. And what they want you to find is T subscript V. Let's just think about this for a second. We've been given one big equation that has all of those variables in it, RC, TC, RV, and TV. And then we've been given several sets of what those variables equal. RV is 60, RC is 50, TC is 5. So we can take these values, substitute them into that big equation, and then there'll just be one unknown, TV, and we can solve for it. So let's go ahead and do that. Let's start substituting into that big equation there. RC is 50 and TC is 5, so we have 50 times 5, plus RV, which is 60. We don't know TV, equals 370. Now 50 times 5, that just equals 250, so why don't we go ahead and subtract 250 from both sides. That'll cancel on the left, and we'll be left with 60. TV is equal to 120. Divide both sides by 60. TV equals 2. And so there's our answer to that relationship. Now, just something to think about here. How many equations were you given? Well, you were given one, this real big one with all the variables in it. 2, 3, 4. Remember, an equation is any relationship where there's an equal sign in it. How many unknowns did we have? We had 4 unknowns, RC, TC, RV, and TV. So what I'm trying to get at here is anytime you want to solve a system of equations like that, you have to have the same number of equations as you do unknown values. So we had 4 unknown values, we had 4 equations. That's why we were able to solve it. If we were only given 3 equations with those 4 unknowns, we could not have solved for TV. We couldn't have solved for any unknowns. So the title of this lesson, it was Systems of Equations. And a system of equations is like a set of equations that work together. Just like your digestive system in your body. That's a system of organs or a set of organs that work together. And that's why it's called a system. Let's do one more. We've been given RATA plus 400 equals RBTB. Then RB is 20, RA is 10, and TA plus 10 equals TB. So we want to find TA and TB in this problem because we don't know either one of those exact values. However, we have been given 4 equations and we have 4 unknowns. So we have to have the same number of equations as unknowns to solve a system of equations like this. So we can go ahead and do that. And always what you should do on these is take that large equation, the one with all the variables in it, and you substitute back into that. So we have RA is 10, so we can say 10 times TA plus 400 is equal to RB, which is 20, and then TB is equal to TA plus 10. So just go ahead and say TA plus 10. And see, now we have one equation with just one unknown in it, TA. So let's go ahead and simplify on the right there. We'll say 10 TA. Let's just rewrite all this. Plus 400 is equal to 20 times TA, or 20 TA, plus 20 times 10, which is 200. Now let's go ahead and simplify this using our addition rule. Let's subtract 200 from both sides and cancel that. And while we're at it, let's go ahead and subtract 10A from, or 10 TA from both sides. And that'll cancel what's on the left. And so we have 400 and a negative 200. That's 200 is equal to 10 TA. So if we divide both sides by 10, we'll see that TA is equal to 20. Now if TA equals 20, go back and look at your original system of equations. TA plus 10 equals TB. So TB must equal 20 plus 10, or 30. And so that's what TB is 30. So those are our two answers. TA is 20, TB is 30. So when you're working with these subscripted variables, they just are a way to write a variable. When you're doing some word problems later on, it might come in handy to use a subscripted variable just to help you describe what's going on within the word problem. More importantly, though, I think for this type of equation or system of equations is that you realize to solve a system of equations, you have to have the same number of equations as you do unknown values. And in problems like these, the best way to solve them is to substitute back into the equation that has the most variables in it. And most of the time, that's the only way you can solve them. Okay, well that's all for lesson 79.